Exponent operations are a key skill on the ACT, and it's tested all over the place, both directly and indirectly. You really need to know what's going on, and I see a lot, year after year, a lot of uncertainty and confusion. So get this stuff down because it's really important. Let's look at some numeric examples. Let's say I have 2 squared times 2 squared. No, 2 to the third. Let's make it a little different. These exponents have the same base, right? 2 and 2. So I could rewrite this as 2 times 2 for the 2 squared times 2 times 2 times 2 for the 2 cubed. And that would be 2 to the 5th, which is, incidentally, 32. You can check that in your calculator if you want. When I have the same base, I'm going to add the exponents. So we counted them up here, right, to the first, second, third, fourth, fifth. But really, I could just do it like this. I could say 2 squared is 3, 2 to the 5th. Let's look at a variable example. Now, it's the same thing. I just kind of show it with numbers first because I feel like that's easier to process. And if you want to fool around with it on your calculator for a minute, you can get the gist of it. If we do the same thing with x, it works the same way. Let's say we have x to the 4th times x cubed. Again, we got the same base here. Multiplying two things with the same base, different exponents. We want to add these exponents together. And if I really wanted to, I could write all these x's out, right? 3, 4 for the x to the 4th, 5, 6, 7. So what do we know so far? Same base. When we multiply, we add. Let's say I have something like this. 2 squared to the 3rd power. Now in this example, I don't have the same base. The base of this cube is actually 2 squared. Base of the cube is actually 2 squared. So I have to take everything in here to the 3rd power. So let's actually work it out arithmetically, and then we'll circle back and talk about the exponents. 2 squared is 4. So now we have 4 cubed. 4 cubed, well, 4 times 4 is 16 times 4 is 64. 4 cubed, 64. I can rewrite that as 2 to the 6th. You can check that math yourself. Make that a little better. Okay. So I don't add the exponents here because that would be 2 to the 5th. What I need to do is I need to multiply them. And let's talk about why. When I multiply things, what I'm really doing is I'm adding them repeatedly, right? So I'm saying this number to the 3rd power, which means 2 squared times 2 squared times 2 squared. 2 plus 2 plus 2 is 6. And the shorthand way to do it is 2 to the 2 times 3. So different base. Whoa. Different base, multiply. Multiply to multiply. And we'll talk about essentially the division equivalent of that roots in its own separate video. Okay, so let's talk about division. Let's say I have 2 cubed divided by 2 squared. Well, let's do it arithmetically, and then we'll come back and talk about the powers. 2 cubed is 8. 2 squared is 4. 8 divided by 4 is 2. Okay. I can also look at it this way. 2 times 2 times 2 over 2 times 2. Remember, fractions, common factors. Factors are things that are multiplied and only multiplied. Boom, 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 boom. I'm left with 2. So it would be 2 to the first. So what am I actually doing here? I'm subtracting the exponents. I can say that this is this. 2 to the 3 minus 2. 2 to the first, or 2. Cool. Let's take a look at the bottom of our screen and look at that problem. And of course, we'll add this up here. When we divide, we subtract. And again, I didn't really go through this on that example, but it's the same principle. The 2's were all the same bases, so they have to be the same basis for you to subtract. The SAT likes that concept, by the way. If you're taking the new SAT, you'll see that a lot, and sometimes you have to make things into the same base to work those problems. So this is kind of a tricky one for a lot of people. We've got negative 3 x squared y to the third power. Now, let's take a quick time out before we get into the math. This is all one single term, right? This is all one thing. I'm not adding or subtracting, which separates from. So this is all just one single number, one single quantity. If it weren't, I would have to multiply it like this, like a FOIL, right? Or in this case, it would be 3 binomials multiplied together. But because it isn't, I can essentially sort of distribute, like I said, distribute the power in. Now, everything has to get taken to the power. I don't leave anything out. Because I'm multiplying this number by itself 3 times. So I can look at it this way. I can say, well, this is negative 3 x squared y times negative 3, put that in parentheses so it's easier. Negative 3 x squared y times negative 3 x squared y. Right? So every single thing is going to get taken to that power, not just the variables, not just the number, everything. That can be a little confusing, especially because of coefficients. When you deal with coefficients on variables, sometimes those things can trip you up. So let's just go ahead and do that. Negative 3 to the third is negative 27. Remember, when I have odd number powers, 1, 3, 5, so on, the sign that the number originally was stays the same. If it's even, it'll always be positive. This is also a good Markov question. I have to multiply these two exponents. X squared times 3, 2 times 3 is 6. So you can go ahead and, just the negative 27 lets you get rid of C, D, and E. The x to the 6 gets rid of A and leaves you with B. So you really only have to do 2 parts of this. And you'll see that time and time again in a good Markov question is you really only have to do 2 or 3 parts, 3 or 4 parts, whatever it is. Of course, the last one, y to the first, 1 times 3, y cubed. So that's all there is on this. Now, there's a couple other videos in this set. There's one on radicals, and then there's one on negative exponents. You'll also find stuff like this in rational expressions, in radical expressions, and really throughout the intermediate algebra section. So take a look at that as well. Work through the problems in this section, because while this is a problem I chose to use, there are several different sort of unique ways they can ask these questions, and you kind of got to get a feel for them. So definitely work through the examples and work through the problem set.